Cameras on, and welcome to AP Statistics. So, before I turn on the camera, I did announce that the practice quiz is out there. The multiple choice on the practice quiz is kind of challenging. I'm going to post both the practice test for Monday's test. I'm going to post both the practice test and the solutions to the practice test. My goal is by 4 p.m. today to have both those posted, so look for those. We're going to start by taking a quick peek at Open Reset. This is a little bit of a, I think I'll find it right here. I think what I'm looking for is in this, sure enough, I picked the right one because on the homework that was due today, which was a practice quiz, and I had posted these solutions, but I just want to emphasize some things. This is what today's quiz is going to look like. 1, 2, 3, 4, 5 parts. It's 20 points, so each part is going to be 4 points. Like section A will be 4 points. It'll be 1 point for writing G of 0.7. If you didn't write G of 0.7, then you're going to lose that point. Because it said, in the directions, it says you have to show the model used. And here's what I'm doing, G of 0.7. I didn't have to write out the whole table, 2-layer table. G of 0.7 is that whole 2-layer table. You have to define your variable. If you did not say, you can't say let x equal attempts or x equals kicks, then you'll lose that point. When you're defining a variable in a geometric setting, the word first has to be in the definition, and it's got to be in context. Let x represent the number of attempted kicks until the first field goal. If you did not use this level of specificity in defining x, then you're going to lose that point on today's quiz. Also, this question can be summed up as, it can be represented symbolically as a probability that x is equal to 3, which, by the way, from the G of 0.7 probability distribution, that means 2 fails and then a success on the third. 0.3 squared times 0.7 for the answer 0.063. So 1, 2, 3, 4 points on part A. Any questions? Like here, I did not define the variable again because it's the same. So that's the only thing I'm going to let you off the hook on is if the variable definition stays the same from part A to part B, then you won't have to write the let statement again. But in part C, notice how the verbiage for defining a variable for a binomial model does not have the word first, but it does have the total, it says out of 6. So here, y, you can't say y is equal to kicks for successful kicks. Y is the number of successful kicks out of 6 attempts. And notice there's a triplet of information here. It's only one triplet. You'll never have to write more than 3 triplets. Here, in part D, you had to write 3 triplets. The k equals 4 triplet, the k equals 5. Notice it's kind of has to be 4, 4, 5, 5, 6, 6, and the k equals 6 triplet. I hope you used 1 minus binom CDF, because whenever it's greater than or equal to, you use 1 minus. So 1 minus, and that's binom CDF of 6. National Public Radio is 6, 0.7, 3. How many of you have been using the National Public Radio mnemonic device in order to remember the triplet of numbers? Okay, it looks like a lot of people. Oceans and oceans of students are raising their hands saying, we're using National Public Radio, Mr. Royce. And then finally, NP and square root of NP. Any questions, concept questions on the practice quiz? Go ahead.
So just like in theory, if we see it like a question that's binomial and it says at least, is that a pretty good indicator that we'll be using 1 minus binom CDO?
Yeah. Yes.
Okay.
Yes. Or the phrase more than.
More than like.
The phrase, more than something or at least
Okay,
something.
at least
both of those are
those.
signals of 1 minus will be
Okay,
utilized.
got you.
Okay. All right. Now, so that'll be a 20-minute quiz at the last 20 minutes of class today. So that the quiz covering this kind of stuff will be, today's today, Thursday, period 6, so 22. So at 1 o'clock. We'll start the quiz at 1 o'clock. Now, between now and then, there's lots of other stuff going on. First of all, I want to make sure you understand what the homework is that's due tomorrow. The homework due tomorrow is problem 2. It's the Donald Trump problem. Take out your homework sheet And let's look at the Donald Trump problem, which is due tomorrow. Now, as I'm taking a look at the homework sheet, problem 1 on the homework sheet was the Lou Malnati's Portillo's problem, okay? That was due last week, Friday, I think. And then tomorrow, problem 2, Fayette County, Texas, Donald Trump received 78% of the 11,000 votes cast in the election. Now, as you do homework problem number 2, I think problem 2E will probably be the most challenging. You're gonna have to pick a model to use. Which model are you going to, quote, launch, unquote, or which rocket are you gonna fly for problem 2E? Take a look at it. It says, and I have an extra one here so I can just hand it to you, even though it is online. But it says, find the probability that the number of voters in the survey that indicated they did not vote for Mr. Trump is more than 130. So tell your shoulder partner, would you launch the normal model, a normal model, a geometric model, or a binomial model? I'll let you talk about that while I pause the camera. We're back. Okay, so which model would you use for trying to find the probability that the survey gets that did not vote for Trump is more than 130? Raise your hand if you think you know which model. Yes, Katie?
Binomial.
Yeah, it is the binomial model, but which binomial model? Specified, there's 2 parameters. National public. N is what in this case?
130.
Actually 500. Because that's the maximum, so that's important. It's important to be able to pick the right binomial model. And what is the probability of success? Raise your hand if you find a shoulder partner who agrees with you for the number, excuse me, the number that goes here. So talk it over. Pause on that one.
Did not vote for Mr. Trump. I thought it said did vote, it's 0.2.
So yeah, it's easy to put 0.78, but it's actually 0.22. And oh, by the way, what is, so okay, by writing this down, do you realize that by writing this down, that means you don't have to write down the 2-tiered binomial distribution, probability distribution table that has how many columns in it? After x and probability of capital X equals lowercase x, you've got the k equals 0 column, k equals 501 columns. There's 501 columns that you don't have to write down because you wrote down this instead. And you would have to define x. In fact, why don't you try it right now? What is going to be your definition for x on problem 2E? Okay, is there a volunteer to define x for the homework that's due tomorrow, problem 2E? Take a volunteer to give this a go. All right, Graham?
So let X equal the number of people out of 500 who did not vote for Trump in Fayette County, Texas.
Excellent. He said, in case you didn't hear it, he said the number of people out of 500 who did not vote for a town in this quiet town of Lafayette, who did not vote for Trump. Not say they voted for Trump. In this survey given in Lafayette. Okay, so you can be specific there. All right, and by the way, probability of what then? Using this x that's now defined, capital X, what would you put in parentheses here? Probability that x is what?
Greater than 130.
Yeah, so you could say greater than 130, or you could say the probability that x is greater than or equal to what? 131. Greater than 130 is the same thing as greater than or equal to 131. Now, would you end up using 1 minus on this, or what?
Yeah.
Yeah.
Oh, yeah, you would, because it's greater than or equal to 2. By the way, class, you're responsible for 3 triplets here. The K equals 131 triplet. So it'd be 131 here. The K equals 132 triplet plus dot, 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 and what would the K value of the last triplet be? Yeah, the K equals 500 triplet. So you would write that down, but you wouldn't have to type it into your calculator. What you would type into your calculator would be, to evaluate this, would be a 1 minus binom CDF expression. So that's just kind of giving you a heads up as to the level of specificity that's required on the homework due tomorrow. All right, so that'll be fun practice for you. Now, I'd like you to take out 2 documents. One of them is your master word picture quiz document, the master word picture quiz. And the other is the rehearsal word picture quiz. You know, the one that has, well, you know what I'm talking about. Do you remember the one that I gave? It's 2-sided and it has numbers filled in down here for practice? So that's going to be the setting. This is going to be the setting for our first GFA problem.
Uh-oh.
So would you please stand up? I'll pause the camera. You have to grab a partner and then move to the other side of the room. And we're back. So in this GFA activity, I want to first of all emphasize that on the master GFA sheet, we didn't fill this in on the bottom. Is that true, that the very last line is
Yeah.
blank? Okay, what are the numbers that are given, or are there no numbers given on your very last line?
On the practice or on the?
On the master one. The master one is blank, right?
Yeah.
Okay, so on the master one, I'm just gonna make one up for you. On the master copy, I'd like you to take the binomial model where n has a value of 75 and the probability of success is 0.43. And over here, we're going to be looking at the probability that x is less than 17. Okay? So if that showed up on tomorrow's word picture quiz, here's what you would be responsible for doing. You would first of all want to say that's the same thing as a probability that x is what?
Less than or equal to 16.
Less than or equal to 16. And since problem 5 is all about calculator syntax, and how is it that you work with like binomial CDF of National Public Radio? What you would do if this were the problem is you would write, for the answer, you would write binom CDF. Can someone tell me what the National Public Radio triplet would be? For x is less than or equal to 16? Just wait for a volunteer. What would the triplet be? See if you know how to use National Public Radio. Dan, you want to give it a go?
I agree.
I'll give it a shot. 75.
Yeah.
0.43. 16.
Yep, that's it. Now, by the way, if it had been P of probability of x is greater than or equal to 40, then you would have rewritten that as 1 minus the probability that x is less than or equal to what? 39 is correct, which would be 1 minus binom CDF of national is 75, public is 0.43, Coradio is 39. So if it had been, instead of less than 17, if it had been greater than or equal to 40, then you would have done it like this. So I just want to make sure that you got the master copy filled in. And then on the master copy, what numbers do you have here?
5, choose 3.
Yeah.
5 and 3. So do you already have 5 NCR3 written down?
Yes.
And would you please take out your calculator, since today's GFA problem is calculator required. I want to make sure that every student in the ocean of students has a calculator.
There are a wave of students today.
In the small ripple, the
This is small class.
tiny puddle, tiny puddle. Yeah, I mean, like during situations like, I remember there was a class last year where Frodo was the only one in the class. think it was senior trip or
This is not senior trip.
something. Right. Yeah, because Frodo was in status last year. All right, so this is coming up. Hey, just type in 5 NCR3 on your calculator. Just want to make sure you remember where to find NCR. Type in 5 NCR3, press enter, see what number comes up, and then show it to me. I just want to confirm that everyone can type that kind of stuff in. NCR3. All right, point your calculator toward me. 5 NCR3. This gives me a chance to find out whether
Your math
your
prep.
fancy math prices.
Never.
Wow, whole class, 100% has rejected math. That's exciting. All right,
Definitely
so
Yes.
now for the GFA problem. The GFA problem comes off of your practice sheet. Would you please, oh, do you have an answer sheet yet?
We do not. No, we don't. Sorry, no.
It's gonna pause.
You just signed it, or
I've already signed
you already signed it?
it. GFA.
I'll just say no.
We actually really fun.
That'd be very funny.
I thoroughly enjoy that. Thoroughly enjoyed this incorrect answer.
Initials, Princess.
Do you have a?
Quiz bank?
No.
Did we say what? Oh, what's your sweat?
Ooh.
Oh, hair been what? That's what we buy off hair. Who would ever do such a thing? Oh, wait.
Oh, wait.
That's just looking like. Are you gonna see this on your report? Dude, well, it's okay, maybe when we were going to Israel, I was like that 30 minutes, I still did.
All right,
Nice.
so,
Is that the GFA for the day?
no,
Done.
there's more.
Oh.
Oh, and by the way, type them in and write out your 3 decimal approximation. 3 or 4 decimals. So this time, type it in.
Wrong. Not for the first part, for the second part. You should do both parts.
Mr. Royce, did you test this before you made it up? It's a little bit.
Is it scientific notation?
Yeah.
It's okay, just write down the scientific notation.
Did you get these? Wait. Is there one minus? No.
G.
Huh?
You need to do a s-
Yeah.
It takes the step from 0 to
What?
yes.
What do you?
this one, G.
But then the second.
On.
Paper, right here. That's what I did.
Oh, okay. I was wondering.
505 on the board.
You're right with you.
Did we put in the same? 125. Wait. Yes. 16. Yes. Okay. And then 4.506 times 10 to the
I mean.
Okay.
Again, my thing, right?
4.2506. I can see that. Oh, okay, good. Okay.
We write down the same thing,
Don't do one minus
Yeah,
that's
okay.
the subtraction. Don't you do
the second one.
You only put eight.
You're not flipping it.
One minus.
No, because if you do the one minus, you flip it.
Flip what?
We didn't flip the other one.
You just need to flip.
Like when you do this, because it's greater than.
Wait, when do you do, like,
Oh.
the lower or higher number?
Just a quick question here.
Yes,
Kate,
yes,
on this one above,
yes.
Okay.
what's inside this one?
On the last
The
one,
G
right?
of,
When we did just this one, we did it with the
0.63.
one minus.
and over
Because
here
it
it
says
says
what
what?
greater than
X
45,
greater
X is
than
greater than
16.
45, we had to flip it, flip the sign.
Okay, while we're waiting, I want you to do the calculator notation and the answer for this one, okay? So how are you guys doing?
So I'm just trying to, debating it. My question was like, for this one, can we just write it as like, just write it as
Easy, that's
I know, but like, do you want us to, or do you want us to write it as, is that fine?
Yeah.
You know what I'm saying over here?
I just thought you did it, I'm confused. When you subtract and when you not
I
subtract.
find you so used to try this when you have the, when you have to flip the sign. He's like, I could be wrong, he's like, I thought.
Here, you write it down.
Very high number. Wait, is this true? Is there one minus? Did that?
Oh, and one more thing, ladies, is that on this, why don't just answer, you just write down the calculator syntax that you used.
Mr. Rose,
Yeah.
when do you do like, when, if it's like the number that's like lower or higher than what's greater?
When it's just plain greater, just plain less than, instead of greater than equal to.
Okay. Is that for geometric CDF also?
Oh, yeah. Yeah.
Okay, wait, so for this one, I was supposed to do 17 then? Wait, no, we do 16.
All right,
Because he wants
Dan
stuff
and
in
Graham,
17.
I'd like you, while we're waiting, I'd like you to do this one also.
Yeah.
G
So for this
8.63,
one-
it sounded GFA problem, but
Just do it, alright.
yeah, just do it.
No, I don't think so. Because like, when you do geometry, it takes all of them from 0 to infinity. Yes. So if you do 1 minus 0 to 16, then you have 17 to infinity.
Zero one minus two, let's see, 6, 3. I don't know.
All right, friends, let's begin with this practice one I asked you to do. So, the geometric model where P is 0.63 is infinitely long, but all the cells add up to 1. So if you're gonna do the probability that X is greater than 16, I recommend you rewrite it, if it's not already with a greater than or equal to or less than or equal to, make it greater than or equal to, so it's x is greater than or equal to what number? Kitty?
17.
17 is correct. So to do greater than or equal to 17, that's the same thing as 1 minus the probability that x is less than or equal to 16. So your calculator notation is going to be 1 minus geomet CDF of public 0.63, Corradio is 16. Public Corradio. It's only binomial that means national public radio. Okay, so 0.6316. Oops, I just opened Kindle to read a book. Okay, it's nap time. I'm going to read a book to you. And so 1 minus geomet CDF 16. I hope you typed in 1 minus geomet CDF of 0.63, comma 16. There it is. Now, by the way, 1.2337 times 10 to the negative 7th. E is the exponent on 10. E cannot be used for any base other than 10. Have you ever tried to use the E button on the calculator for a base other than the number 10?
No.
That's good. Like for example, 1 E, by the way, is the double E here. 1 times 10 to the negative 2nd is the same thing as 1 times 10 caret negative 2, should be the same thing. So, which is also the same thing as 0.1. So when you're looking at 1.23 times 10 to the negative 7th, excuse me, make sure the camera was running so we could document that event. 1.23 times 10 to the negative 7th, those of you playing the game at home, you are responsible for knowing how to get this into decimal form without scientific notation. So I hope you know the way that math works is that 1.23 times 10 to the negative 7th, you go 1, 2, 3, 4, 5, 6, 7. Move the decimal point 7 places left, so it's 0.00000. 1, 2, 3. Just review of converting scientific notation to decimal form. Now, 4.
Do we have to write it in decimal form?
I mean, you're responsible for knowing how to convert scientific notation into decimal form. That much I'll tell you. Because if you're in a multiple choice setting and the answers to choose from are not in scientific notation, but rather in decimal form, then you've got to know how to make the conversion. Kind of a scary situation. But this one should be, for the GFA game, we're looking at binom CDF of national 100, public, Corradio is 30, and this one is going to be probability that x is greater than or equal to 46, which is 1 minus the probability that x is less than or equal to 45, or 1 minus binom CDF of national 100, public 0.25, Corradio is 45. So that's what I was looking for. You also got to be able to type that in.
Okay, why is it 45?
So 100.25, 30, 1 minus 100.25, 45. Where to go? This.
Go for 2.
So you type it in correctly.
No.
Yeah, there you go.
Yeah.
Way to go, Val. And let me just. So the question on the table now is, why is this a 45 instead of a 44? Or 45 instead of a 44, right? Okay, so
Yeah.
do all the steps. Greater than 45 is the same thing as greater than or equal to 46. Keep in mind how many cells are there to choose from. There's 101 cells in this table because it starts from k equals 0, k equals 1, all the way up to k equals 100. So cell k equals 46 to 100 can be found by taking the other ones. Instead of 46 to 100, take 1 minus 0 up to 45. So instead of 46 to 100, we're going from 0 to 45 and subtracting from 1. Okay? And that's really why we're doing these GFA problems today, because this is going to have to be on tomorrow's word picture quiz. It's going to be rapid fire, you know? I mean, you're rehearsing this to be able to get it down to 8 minutes or less. And I'll give you 10 minutes for tomorrow's quiz. That way you'll be able to do it in 8 minutes, and then you'll take 2 minutes to look it over, make sure you didn't make any silly mistakes. So that's the plan for the GFA quiz tomorrow. These numbers down here will be different. The rest of it's last call for questions on this GFA problem. Okay. Now we're going to learn the new material. We have 20 minutes. We're going to wrap up Unit 7. This will be the last chunk of new material in Unit 7. And then at 1 o'clock, we'll take the quiz. So that's the plan for today. You have, hopefully in front of you, Probability Models, Part 3 of 4. Now, we're going to fill in word picture number 4. And since I'm just teaching you word picture number 4, I'm not going to make you fill it in on tomorrow's quiz. If you have extra time you want to, I mean, I'd love to give you extra credit, except can't, sorry. But would you please fill in word picture number 4, have that out ready to go, so you have 2 documents out. The master word picture quiz will be filling out word picture 4, and then don't forget about the notes for today, which is probability models part 3 of 4. So here we go. Consider the binomial model, which is this topic of word picture 3. Turns out that word picture 4 is an approximation for word picture 3. Word picture 3, we have the binomial model. And in word picture 4, the name of it is the normal approximation of the binomial distribution of random variable x. So word picture 4 gives us a streamlined approach to approximate the answers that come from word picture 3. Word picture 3 is binomial, which is related to Pascal's triangle. Let's take a look at the shape of some of the distributions represented by rows of Pascal's triangle. Like 1, 5, 10, 10, 5, 1. Let's take a look at that one. If I were to come up with a distribution of, if I were to add these up, 20, 30, of 32 BBs, so you have 32 small steel balls or BBs. It's like in the first bin there's 1, and then 1, 2, 3, 4, 5 in the second bin. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 BBs. In the third, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 1. What do you notice about the shape of that distribution? Yeah, it looks like a bell. It looks unimodal and symmetric. In fact, so it looks like a normal model might approximate what's going on in this binomial model. Let's take a look at the next row, which is 1, 6, 15, 20, 15, 6, 1. This one's even more bell curvy. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16, 17, 18, 19, 20, 15, 6, 1. So you can kind of see that bell curve shape. So you can use a normal model to approximate a binomial model if the it's called the success failure condition holds. So there's nothing here on word picture 4. You don't have to worry about anything over here because it's already binomial. If it's binomial, then all you have to do is look at right sideways here, NP and NQ. NP is the expected number of successes, and NQ is the expected number of failures. If the expected number of successes is, here it is, greater than 10, and if the expected number of failures is greater than 10, then go ahead and use a normal model that has a mean of NP and a standard deviation of the square root of NPQ. So the mean will be mu sub x as defined by this equation, comma, the standard deviation will be sigma sub x as defined by that equation. So that's all there is to word picture 4. Word picture 4 is short, it's done. You'll probably have no problem doing it on tomorrow's quiz. I'm just not going to make you do it the day after you learned it, but there it is. So now the word picture quiz is complete. The master copy. Let's find out what this means. On the Trump problem that you were working with, I mean, can you use the binomial 500 voters are surveyed, 22% of them say they did not vote for Trump. Could I approximate that? Well, let's find out what NP is. NP is 500 times 0.22. Let's see if that's greater than 10. Okay. I mean, it's got to be, because 10% of 500 is 50. 20% is 100. So yeah, it's way more, but we have to show it over. N is 500 times P is 110. So 110, which is greater than 10. So the success condition has been satisfied. The expected number of successes is greater than 10. Let's take a look at NQ. Now remember, Q is just 1 minus P. It's the probability of failure. So that would be the 0.78. That would be the other, well, all I have to do, I don't have to use a calculator, just take 110 away from 500, 390. So it'd be 390, which is also clearly greater than 10. Therefore, I could use a normal model with a mean of 110 and a standard deviation of whatever the square root of 500 times 0.22 times 0.78 is. And that model would give me answers that would be pretty close to the answers given by the binomial model. That's today's lesson. Now all we have to do is an example of this. And if you page forward to the tennis anyone problem, tennis anyone? Anyone? Tennis? Where? Okay, still more lefties, blah, blah. Tennis anyone? Woo, we made it. Okay. Now, we're gonna do this problem first with the binomial model, and then we'll approximate it. So this will be a review. Tennis, a certain tennis player makes a successful first serve 70% of the time, assuming that each serve is independent. So what sports have we done in stances here? We've done cross-country problems, girls basketball, guys basketball, we've done football, tennis. Are there any other sports? There's wrestling.
There is.
What?
Golf.
There's golf. Didn't we do a golf problem? I thought we did distributions of the opening drive. So, okay, so assuming each serve is independent, if she serves 6 times, what's the probability that she gets the first, she gets all 6 serves in, all 6 serves. And by the way, you do have to check the conditions for lunch in this model, so be prepared to do that. The test, we practice on this, so here we go. So, yep. First serves can be considered Bernoulli trials. Why? Because there's only 2 possible outcomes, successful and unsuccessful. The probability of the first serve being good is constant at 0.7. Finally, we assume that each serve is independent of the other. Since we're considering a fixed number of successes, on n equals 6, we're going to use the binomial model. Binom. Some people write binom, but you don't have to. All you got to do is write B. It's kind of, what? Binom? Excuse me? Okay, so B of 6, 0.7. So we're trying to find if X is the fixed number of serves that are actually in n equals 6 serves. So see if you can do part A on your own. Find the probability that all 6 serves are in. I'm sorry, it's already done for you?
Yeah.
All right, so all 6 serves, so yeah, let's just kind of reviewing, it's already done. It's a triplet. It's the last triplet, 626, 0.76, 0.30, which comes up to 0.18. How about exactly 4? Is that one done for you also? Do you have some parts to do in that one?
Yeah.
Okay, go ahead and finish up exactly 4 serves every game. Oh, you just have to do the triplet. Now make sure you put that 640. And also type in your calculus. So 6 and 0. Okay, so we're finishing this one. I'm going to pause the camera. So I did finish the setup up here. And if you're on the calculator, doing this. Do some quick coaching here. I would recommend you type this in as 6 NCR4 in parentheses. Use a time sign, 0.7 caret 4. Use a time sign again to get 0.3 caret 2. That should give you the 0.324. And is there work for you to do on part C? Let's take a look. Part C. Part C, so it's, yeah, fill in the probability x equals 4 plus probability x equals 5 plus probability x equals 6. So you're filling in the 4, 5, 6. Now, see if you can get the answer on your calculator by using the appropriate keystroke. So I'm going to pause as you try to finish this one up on your own. All right, so we got this up here. This is nice to be able to get some good practice on using binom CDF. So let's pause here. Any questions on this particular page? There's more to the tennis anyone problem. But we good? Is this moving too fast, or are we ready to go to the next page? All right, let's go on to the next page. Okay, no more than 4 serves in is either 0, 1, 2, or 3, or 4. Notice how 3 triplets, even though there's 1, 2, 3, 4, or 5, some people might end up wasting their time and write down 5 triplets. Please don't waste your time. Just write down the first triplet, the second triplet, and the last triplet. And then go to binom CDF to get 6. National Public Radio gives you 0.58. Any questions there on that one? Okay, let's move on to number 27. More tennis. Woohoo! Suppose a tennis player in exercise 25 serves 8 times in a match. By the way, could we have used a normal model up here? Let's look at NP. NP is 6 times 0.7 on the previous problem. 6 times 0.7 is 4.2. 4.2 is less than 10. So a normal model approximation would not have been warranted. I mean, you don't even have to check NQ. NQ, if one fails, they both got to succeed. N times 0.3 is 1.8, is also less than 10. Okay, so sorry, we haven't made it, we're at row 6 of Pascal's triangle. Row 6 is not close enough to the bell curve to be able to use a bell curve. You've got to go farther down. What if we're serving 80 times? Let's do a quick check on this. Let's look at NP here. What's 80 times 0.7? Yeah, 56 is greater than 10. What's 80 times 0.3? 24. They're both greater than 10. So we're going to be able to use a normal model approximation here when they give us a, yeah, go ahead.
So a normal model approximation, if just one of them is above 10, the other's not above 10, it's not viable?
It's not viable.
They gotta both be.
They've got to, both NP and NQ have got to be greater than 10. They've both got to be greater than 10 to use a normal model. Okay. So, it's a good discussion. Want to make sure that got on the video. So, here we go. We're not using the normal model yet. Say 2 possible outcomes, successful, successful. Fixed, 80.7. Fixed number of serves out of 80. What are the mean standard deviation of the number of serves? So NP is 56, standard deviation is 4.10 for serves in. Verify that you can use a normal model to approximate. So here's how you, okay, the independence assumption. This, okay. On word picture for,
Gotcha.
I mean, once it's already binomial, you don't have to look at the independence assumption or the so independence condition 1, yeah. But you do have to look at the sample size assumption. Sample size assumption, sample can't be too big or too small. So it's got to be less than, 80 is less than 10%. Look, it's just NP and NQ. NP and NQ are both greater than 10, so we're good to go. So we can use the binomial model with a mean of 56 and a standard deviation of 4.10. Really, all you have to do is, this is not required, all you have to do is say that MP and NQ are both greater than 10. Let's go to the next page. So, I don't want to take the time to do part C. If you were to do part D, using the binomial model, she makes at least 65 of the first serve, so it's 65 or more. You put the triplet for k equals 65, k equals 66, and k equals 80, and binomial CDF can be used to get that. So let's see what the normal model gives you for the same problem. This is the number we're shooting for. The exact answer is 0.0161. How does the normal model do? The normal model is, let's draw this out. Normal model approximation is titled first serve is made out of 80. It has a mean of 56, standard deviation of 4.10. And at least 65, so it's 65 or more. So let's put the boundary marker at 65 and shade everything to the right. So the area of this shaded region should be approximately 0.0161. We need a z-score, so z equals x minus mu over sigma. X is 65, mean is 56 over 4.10. 65 minus 56. Okay, so we have a z-score of 2.195. Z equals 2.195. So go to normal CDF. Let's knock this out. Should get 0.0141. That's pretty close. It's at 0.0161. The normal model gave 0.0141, which is almost the same thing. So according to the normal model, the probability that she makes is approximately 0.0141. That's not the exact probability, but it is an approximation. So I just want to make sure you have that example. That completes Unit 7. So it's normal approximation. We have the rest of the class today to take the quiz, so clear your desk completely, spread out, and we'll get started.